In this video, we are going to discuss about finding maximum and minimum element using divide and conquer algorithm. Divide and conquer algorithm is implemented using three steps. The first step is divide, the second step is conquer, whereas the third step is combine. So the first one is divide, second one is conquer, third one is combine step. In divide step, the given array is divided into two parts. In conquer step, each subproblem, each sublist is solved recursively. In combine step, the solutions of the subproblems, sublists are merged or combined. Let us see how we can find out maximum and minimum element using divide and conquer algorithm. Let we have an array which contains n elements. Let us see first an example, and then we will see algorithm as well as how to find out time complexity for finding the maximum and minimum element. Okay, let us see the example. Here the size of the array is 7 elements. So we can have 0 to 6. So the size is 7 elements. So we can have 7 elements like this. Okay. So the first element is treated as I. So it is nothing but low value. Whereas the last element is nothing but high value. So if n value is 7, then high means n minus 1. Why? Because in this problem we have taken starting index as 0. So low means 0, high means 6. So what is the first step? Divide step. Divide and conquer algorithm is implemented using three steps. The first step is divide step. In divide step, the given array is divided into two parts, just like binary search. So we can divide the array into two parts by calculating the mid value. The formula for the mid is equal to low plus high by 2. So here low means 0, high means 6. So 0 plus 6 means 6. So here low plus high means numerator. So first we have to calculate numerator, and then here, this 2 is nothing but denominator. So 0 plus 6 means 6. So 6 by 2 means 3. So now mid value is 3. Okay. So now we can have two lists. So this is list 1, this is list 2. The size of the list 1 ranges from low to this mid value, whereas list 2 ranges from mid plus 1 to high value. Okay. Here what is mid value? 3. So list 1 contains the elements from low to mid value. So here low means 0. So mid means 3. So the first list 1 contains the elements from 0 to 3. Okay. 0 to 3. So low to mid. Okay. So 0, 1, 2, 3. So 0, 1, 2, 3 elements are 7, 10, 13, 71. Whereas if we consider this one, what is the second list here? The second list contains the elements which ranges from mid plus 1 to high. So here what is mid value? 3. So mid plus 1 means 3 plus 1. 3 plus 1 means 4. So 4 to high value is 6. So list 2 contains the elements from 4 to 6. So the elements are 32, 83 and 2. Okay. So this is nothing but divide step. So dividing the array into two parts. And we know what is conquer step. So conquer means solve each list recursively. So we have to solve each list recursively. Okay. So again we have to solve this list as well as we have to solve this list by calculating the mid value. So we know the formula for the mid. Mid is equal to low plus high by 2. So here low value is 0, whereas in this list what is high value? 3 is high value. So 0 plus 3 means 3. 3 by 2 means 1. So now mid is 1. Okay. So list 1 contains the elements from low to mid. So list 1 contains the elements from low to mid, whereas list 2 contains the elements from mid plus 1 to high. So here low means 0. So mid means 2. So list 1 contains the elements from 0 to 1, whereas list 2 contains the elements from mid plus 1 to high. So here the mid value is 1. So 1 plus 1 means 2. So 2 to what is high value? 3. So 2, 3 means 1371. Okay. So likewise, we have to solve this list also recursively. So once again, we have to calculate the mid value. So for this list, low value is 4, high value is 6. So we know the formula for the mid. Mid is equal to low plus high by 2. So 4 plus 6 means 10. So 10 by 2 means 5. So now mid value is 5. Okay. We know that list 1 contains the elements from low to mid. So what is low value? 4. Mid value 5. So list 1 contains the elements from 4 to 5. So 4 to 5 means 32, 83. Whereas list 2 contains the elements from mid plus 1 to high. So what is mid plus 1 here? 5 plus 1. 5 plus 1 means 6. So 6 to 6 means here we have only one element. So likewise we have to do the conquer step. Conquer step. So we have to solve each list recursively as long as the list contains either one or two elements. Here the list contains 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 one element. So we have to stop the conquer process. So how long we have to continue this conquer process? We have to solve this problem as long as the list contains either one or two elements. Either the list contains either one or two elements. Okay. So let us see here. Here the list contains 7 and 10. So compare 7 and 10. So which is the maximum value? Which is the minimum value? So maximum value is 10. So minimum value is 7. So maximum value is 10. Minimum value is 7. Okay. If you take the second list, 1371. So what is the maximum value? Maximum value is 71. Whereas the minimum value is 13. And what is the last step here? Combine. So combine means here doing the comparisons and finding which is the maximum element and which is the minimum element. So combine the solutions of the subproblems. Here combining means comparing the maximum and minimum element. So if we compare this maximum 10 and this maximum 71, 10, 71. Compare this maximum element with this 71, this maximum element. So out of 10 and 71, 71 is the biggest number. So max is equal to 71. Next you compare this minimum element, this list minimum element with this list minimum element. So out of 7 and 13, which is the minimum element? 7 is the minimum element. Okay. So that's why here. So if we have two elements, so then one element will become the biggest element and the other element will become the smallest element. If the list contains only one element, then that element will become both biggest and smallest element. So if you do here 30 to 83, here we have two elements. So biggest element is 83. So maximum is 83. Whereas smallest element is 32. Okay. Whereas here we have only one element. If the list contains only one element, then that element will become both biggest and smallest element. So maximum is 2, minimum is 2. So that's why in conquer step, what we are doing, we are solving the problem recursively as long as the list contains one or two elements. As long as the list contains one or two elements. If there are two elements, then one element will become maximum element, another element will become the minimum element. Whereas if the list contains only one element, then that element solely will become both biggest and maximum. Okay. So max, compare this list with this list. Out of 83 and 2, 83 is the biggest element. So max is 83. So out of 32 and 2, which is the minimum element? 2 is the minimum element. Now we have to compare this list 1 max with list 2 max. List 1 max is 71, list 2 max is 83. So out of 71 and 83, 83 is the biggest element. Compare list 1 minimum with list 2 minimum element. 7, 2, which is the minimum element? 2 is the minimum element. So out of all these elements, 83 is the biggest element and 2 is the smallest element. So like this, we can find out maximum and minimum element using divide and conquer algorithm. Now let's see the algorithm. Name of the algorithm is max min. It is accepting 4 parameters here: low value, high value, max value, min value. Okay. Let us see the procedure here. If low double is equal to high, that means if the list contains only one element, then what will happen? That element will becomes both maximum element and minimum element. So that's why max is equal to min is equal to A of low, or we can write as A of high also. Here A means array name. So A of low means that element will be stored. Okay. That element will be stored. Okay. So let here the list contains only one element. Let here the index is 3. Okay. Then what will happen here? The low value is 3, high value is 3 only. So max is equal to min is equal to A of 3. So that means in max and min 30 will be stored. Okay. And now let's see the second condition. Else if low double is equal to high minus 1. So that means if the list contains two elements, so let here we have a list like this. let the list contains two elements. Let low value is 0, high value is 1. Let here the first element is 10, second element is 20. So what is low value? Low value is 0. What is high value? 1. Okay. Low value is 0, high value is 1. Here what is the condition? Low double is equal to high minus 1. 0 double is equal to what is high? 1. So 1 minus 1 means 0. So 0 double is equal to 0. Condition is true. So this condition will get executed if the list contains two elements. If the list contains two elements, then we have to compare those two elements. The maximum element will be stored in max variable, minimum element will be stored in the min variable. Okay. If A of low is greater than A of high, so that means the first element is the biggest element. The first element is the biggest element, whereas the second element is the smallest element. Okay. So max will becomes A of low, min will becomes A of high. So max will becomes 20, min will becomes 10. Okay. Whereas else. So when this else block will get executed, if A of low is less than A of high, if A of low is less than A of high, so 10 is less than 20, 10 is less than 20, condition is true. So now max will become A of high. So max will become 20. So min will become what? 10. Okay. Or here we can have some 6 and 7. Here we can have let the list contains two elements where the first element starting index is 6, second element index is 7. Okay. So low value is 6, high value is 7. Here what is the formula? Low double is equal to high minus 1. 6 double is equal to 7 minus 1. 7 minus 1 means 6. Okay. So this condition is for if the list contains two elements. So if the list contains two elements, then we have to compare those two elements. The biggest element will be stored in the max, smallest element will be stored in the mean. Whereas this condition is for if the list contains only one element. If the list contains only one element, that element will become both biggest and smallest. Okay. Else, so this else block will get executed if the list contains more than two elements. If the list contains more than two elements. If the list contains more than two elements, then which approach we are using? Divide and conquer algorithm. We know that divide and conquer algorithm is implemented using three steps. The first step is divide step. In divide step, the given list is divided into two parts. Here we have low and high. So the initial value is stored in low index, whereas the last value means what? High index. So how to calculate the mid? So mid is equal to low plus high by 2. So this is nothing but divide step. Divide step. And what is the second step? Conquer step. So conquer means list 1 as well as list 2 are to be solved recursively. Are to be solved recursively. So here list 1 contains the elements which ranges from low to mid, whereas list 2 contains the elements which ranges from mid plus 1 to high. Okay. So max min of list 1 contains the elements ranges from low index to mid index. So low comma mid comma. So max comma min. So max comma min. So we are passing those values. So now it will goes to this function and based on that it will be evaluated. So this is for list 1. List 1 conquer step. So in order to solve list 1 recursively, we are using this step. Next, let us see the next step. What is the next step? Solving list 2 recursively. We have to solve list 2 recursively. List 2 contains the elements which ranges from mid plus 1 to high. Mid plus 1 to high. So max min of here low value means mid plus 1, high value means high. Here in order to eliminate the confusion, what I am doing is in place of max we are using max 1. In place of min we are using min 1. So this is for list 2 solving. Okay. In order to solve list 2 recursively, we are using this step as well as this step. So conquer is over. So next we have to perform combining. So what is combining step? So here after executing this function call, that maximum value is available in max, minimum value is available in min variable. Likewise, after solving this list 2, maximum value is available in max 1, minimum value is available in min value. Okay. So here combining means combining the solutions of the two lists. Here combining means making the comparison between max and max 1, min and min 1. So if max 1 is greater than max, that means max 1 is having higher value. So then what we have to do? We have to store max 1 in max variable. So now maximum is available in max variable. So if here list 1 minimum element is available in min variable, list 2 minimum element is available in min 1 variable. So compare min 1 and min element. Suppose if min 1 is smaller than the min element, then min is equal to min 1. So min contains minimum 1 element. Okay. So in this way we can write the algorithm for finding maximum and minimum element. Now let's see how to find out the time complexity. Let's see how to find out. Now let's see how to find out the time complexity. Here T of n means time complexity for an array of n elements. T of n is equal to, within the curly braces, if the list contains only one element. So that means if n is equal to 1, if n is equal to 1, then how many comparisons are required? 0 comparisons. Why? Because that element will become both maximum and minimum element. So we require only 0 comparisons. Okay. Whereas if the list contains 2 elements, if the list contains 2 elements, then we require one comparison. Let the list contains 2 elements. Then we have to make comparison between 10 and 30. So we need one comparison. Okay. Whereas if the list contains more than 2 elements, if the list contains more than 2 elements, then the recurrence relation here is, here here we have some elements like this 10, 30, 40, 50. Here we have to divide the list into two parts. Okay. So here the recurrence relation is 2t of n by 2 plus 2. So here why we have taken this 2? Why? Because here we have two parts. Okay. These are the elements here. Here we are dividing the list into two parts. Where each part contains n by 2 elements. So let we have several elements like this 10, 20, 30, 40, 50, 60, 70 likewise. So likewise we have 8 elements are there. So we have to divide this list into two parts. So the first part contains 4 elements. The second part contains 4 elements. Okay. So this is nothing but T of n by 2. T of n by 2. T of n by 2. So initially we have 8 elements are there. 8 elements are there. So now the list 1 contains 8 by 2, 4 elements, whereas list 2 contains 8 by 2, 4 elements. So again we have to divide this list into two parts. So here we have 4 elements are there. So list 1 contains 10, 20, list 2 contains 30, 40. So here why we have written 2t of n by 2. Here we are dividing the list into two parts, where each part contains n by 2 elements. So this 2 for dividing the array into two parts, and this T of n by 2 for each list contains how many elements? N by 2 elements. Okay. So we have to calculate time complexity for n by 2 elements. Next we have to add 2. So why we are adding 2 here? 1 here out of 2, 1 is for division purpose. We have to divide the array into two parts, and another one for combining step. So after solving the first list and second list, we have to compare max and max 1. We have to compare min and min 1. So we need minimum 1 comparison. So one is for division step and the second one is for comparison purpose. Okay. So 1 plus 1 means 2. So that's why we have added 2 here. So now let us calculate the time complexity based on this recurrence relation. 2t of n by 2 plus 2. 2t of n by 2 plus 2. So let us calculate that. So T of n is equal to, so what is the formula? T of n is equal to 2t of n by 2 plus 2 is equal to 2 into, here we can substitute T of n by 2 formula. So that means in place of n, we have to substitute n by 2. So 2t of, here we are deriving n by 2. So if we substitute n by 2 in place of n, we will get n by 2 by 2. So that means n by 4. So 2t of n by 4 plus 2 plus 2. Okay. So this is nothing but t of n by 2. T of n by 2. What is t of n by 2 formula? 2t of, in place of n, we have to substitute n by 2. So n by 4 plus 2. So next we have these 2. Okay. So what is the term here? So 2 into 2, 4t of n by 4 plus plus 2 into 2 4 plus 2. Okay, let us derive one more term. So 2 into 2 means what? 4. 4t of. Now let us derive t of n by 4. Let us derive t of n by 4. So that means in place of this n, we have to substitute n by 4. So 2t of, if you substitute n by 4 in place of n, then n by 4 by 2. So that is nothing but n by 8. N by 8 plus we have to write what? This 2. This 2. This 2. So now we have calculated what? T of n by 4. So this is nothing but the formula for T of n by 4. Next we have two more terms such as 4 and 2. Okay. We have two more terms such as 4 and 2. Okay. So this T of n by 4 formula is this one. 2t of n by 8 plus 2. Okay. So if we derive this one, 8t of, why? Because 4 into 2 means what? Yeah. 4. Yeah. This is nothing but 2 only. So 2 into 2 means what? 4. Okay. Yeah, 4 into 2 means what? 80 of n by 8 plus 4 into 2. 4 into 2, 8 plus we have two more terms, 4 and 2. Okay. So this can be written as 2q t of n by 2 power 3 plus, here we have 8. 8 can be written as 2q plus 4 can be written as 2 power 2. 2 can be written as 2 power 1. So likewise we can written this equation as 2 square into t of n by 2 square plus, so what is this 4? This 4 is nothing but 2 power 2, whereas 2 is nothing but 2 power 1. So on. We can write the last term as t of n is equal to, let the last term is denoted by k minus 1. So 2 power, here we have 3. So let the last term is denoted by k minus 1. So 2 power k minus 1 into t of n by 2 power 3. So 2 power k minus 1. So plus after that, here we have 2q plus 2 square plus 2 power 1. Okay. So this can be written as sigma I is equal to 1. What is the last term? K minus 1. So 2 power I. So if we see here, if you observe here, let k value is 4. If k value is 4, then we will get the last term. Whereas if k is 3, then we will get the last but one term. So that is this term. Okay. So let k value is 4. Then sigma I is equal to 1 to k minus 1 means what? 4 minus 1. 4 minus 1 means 3. Okay. So if we substitute 1 here, then 2 power 1. We will get 2 power 1. So next we have to continue up to 3 here. So next to 2 power 2. Next to 2 power 3. So likewise. So here also if we substitute here, 2 power k minus 1. K minus 1 means 4 minus 1. 2 power 4 minus 1 means 2 power 3. So 2 power 3 into t of n by 2 power k minus 1 means 2 power 4 minus 1, 2 power 3. So t of n by 2 power 3. So likewise this is nothing but the last term. Now let us derive this one. Yeah. So this is the last term. So now let us calculate this equation. So how we can get the time complexity by solving this equation. Here this is the kth term, the last term. So t of n is equal to 2 power k minus 1 into t of n by 2 power k minus 1 plus sigma I is equal to 1 to k minus 1 2 power I. So now we have to derive this equation. So let us derive this equation. So 2 power k minus 1. So this is in the form of a power m minus n. A power m minus n is equal to a power m by a power n. So this can be written as 2 power k by a power n means 2 power 1. So 2 power 1 means 2 only. So into t of n by, so this is in the form of a power m minus n. A power m minus n means a power m by a power n. So 2 power k by 2. So the denominator 2 will become numerator now. So this is nothing but 2 power k. Okay. So 2 power k by 2. So this 2 will become numerator now. So plus sigma I is equal to 1 to k minus 1 2 power I. Okay. 2 power I. Now in order to solve this equation, let us assume that 2 power k is equal to n. Let 2 power k is equal to n. So if there is 2 power k in the equation, then we have to simply substitute n there. Okay. So this can be written as, in place of 2 power k, we have to substitute n. So n by 2 into t of 2 into n by, so in place of 2 power k, we have to substitute n. So n, okay, plus we have to derive this equation. This is nothing but geometrical progression equation. Geometrical progression equation formula is a into r power n minus 1 by r minus 1. R minus 1. So here what is this equation? This equation is in the form of like this. So 2, what is the second term? The second term is 4. The third term is 8. What is the first term? 2 power 1. 2 power 1 means 2. What is the second term? 2 power 2. 2 power 2 means 4. What is the third term? 2 power 3. So likewise we can write n number of terms. Here what is a value? The first term will become a value. So a is equal to 2. What is the second term? So here we will get 4 by multiplying 2 here. So 2 into 2 means 4. So 4 into 2 means 8. The next term is 8 into 2 means 16. So here the multiplier is 2. So that multiplier is called as R value. So R value is also 2. So in order to calculate this, we know about sigma. Sigma means summation. Here the formula for the sum is a into r power n minus 1 by r minus 1. Okay. So a into, so what is a value? 2 into r power n. R power n. What is r value? 2. What is n value here? Here the final value is k minus 1. We have to continue up to k minus 1. So 2 into 2 power k minus 1 minus 1. Okay. Minus 1. So minus 1 by r minus 1. What is r value? 2. So 2 minus 1 means 1. So 1. So we have to solve this equation now. So let us solve this equation now. So this can be written as 2 into 2 power k minus 1 minus 2 into 1 means 2. So by 1 means there is no change. So 2 into a power m minus n. A power m minus n means a power m by a power n. So 2 power k by 2 minus 2. So we can cancel this 2 and this 2. So what is the equation now? 2 power k minus 2. So if we solve this entire equation, then we will get 2 power k minus 2. So 2 power k minus 2. So what is 2 power k? We are assuming 2 power k as n. So plus we are assuming 2 power k as n. So n minus 2. Okay. So now let us solve this one. So here we have n by 2. So n by 2 into t of 2n by n means we can cancel this n and t of 2 plus n minus 2. So we know the formula for t of 2. So already we have calculated that. Okay. So is equal to n by 2 into, if we have only one element, then zero comparisons are required. Why? Because that element will become biggest and smallest element. Whereas if we have two elements, then we require one comparison. So t of 2 means what? 1. If there are two elements present in the list, then we require one comparison in order to find out biggest and smallest element. So t of 2 means 1. So plus n minus 2. Okay. So n by 2 into 1 means what? N by 2 plus n minus 2. So if we derive this one, so 2. So 2 into 1 means 1. N. 1 into 2 means 2. So 2n minus 2. So this is nothing but 3n. N plus 2n means 3n. 3n by 2 minus 2. So this is nothing but the time complexity, the best case time complexity, worst case time complexity, average case time complexity in order to find out maximum and minimum element. So here we know how to calculate the time complexity here. Here in order to calculate the time complexity, we have to ignore the constant multipliers. Okay. The constant multipliers, as well as we need to consider higher exponent. Here we have only one exponent, that is n power 1. So we need to consider this one only, 3n by 2. So here what is the multiplier? 3 by 2. So we have to ignore 3 by 2. So what is the time complexity here? N. So theta of n is the best, worst case, average case time complexity in order to find out maximum and minimum element using divide and conquer algorithm.